on. Lesson 3. Let's start up with a warm-up. Determine h of given value, given the function h of x equals negative 2x minus 5. In number 1, my input is 3. So I'm going to have negative 2 times 3 minus 5. Negative 2 times 3 gives me negative 6 minus 5. That's going to give me negative 11 as my output. Number 2, first let's start with the input of negative 2 into the function. So negative 2 times negative 2 minus 5 gives me 4 minus 5, which is negative 1. And then I'm going to multiply all that by 2, which gives me negative 2 for my final answer. Number 3, I'm going to start with putting my input in for 1. So negative 2 times 1 minus 5 gives me negative 2. Negative 2 minus 5 gives me negative 7. And then I'm just going to apply the order of operations. So negative 1 times negative 7 plus 5. So I want to multiply first. That gives me a positive 7 plus 5 gives me a positive 12. And number 4, again, we want to put in our input. So negative 2 times 0, take away 5, will give me negative 5. I'm going to multiply by 5 and then add 5. So do your order of operations first. 5 times negative 5 is negative 25, plus 5 gives me a negative 20. Here's our learning goals and our key terms that we're going to look at. You have learned about linear functions and their characteristics, including slope and y-intercept. How can you transform a function? What effects do different transformations have on the characteristics of linear functions? Getting started. Returning to transformation station. Consider the line segment AB with coordinates -8, -8, and B, 8 and 8. Follow your teacher's instructions to copy this line segment on a coordinate plane on the floor of your classroom with different students standing at different points of the line segment. So let's imagine this. Move on the coordinate plane to translate the entire line segment up 4 units and then down 4 units. Describe how the students' points move. Let's look at this. So imagine this graph on the left. You have some students standing on the floor, and we are going to transform this line segment. And it says first move on the coordinate plane to translate the entire line segment up 4 units. Up 4 units. So we're going to go 1, 2, 3, 4. So here we can see how the line moved up 4 units. And then if we move this graph back down 4 units, we'll go back to the original graph. Number 2, how do the translations affect the coordinates of the figure? Well, if we're moving up 4 units, my x is going to stay the same, but my y is going to have 4 units added. If I'm going down 4 units, my x is going to stay the same, and I'm going to take away 4 units from my y. Number 3, draw a line CD on the coordinate plane so that a vertical translation of AB up 4 units. Compare the two line segments, describe how they're related. So if we go back to our picture, here we had CD and it's parallel to CB. Number 4, move back to where you started. Then multiply all the y-coordinates by 2 and then by -2. Describe how the student points move. So remember that coordinate A was -8 and -8, and coordinate B was 8 and 8. Oops. So it says multiply all the y-coordinates by 2 and then by -2. So A becomes -8 and -16, and B becomes 8, 16. Then we'll take A and B again, and then multiply by -2. So A changes into -8 and +16, and B changes into 8 and -16. The movement of the points causes the line to stretch vertically or be steeper. The factor is negative, the points reflect across the x-axis. The image is steeper than the original. Let's look at 5. Draw EF on the coordinate plane by multiplying all of the y-coordinates of AB by 2. Compare the two line segments. So if we take AB and multiply all the y-coordinates by 2, A is going to be -8 and -16. B is going to be 8 and 16. So when we draw this on a coordinate plane, the image is going to be much steeper than the original. Number 6, draw GH on the coordinate plane by multiplying all the y-coordinates of AB by -2. Compare the two line segments. So we said that that was going to be +16 and -16. So here the image is steeper than the original and it reflects across the x-axis. Activity 3.1, vertical translations of functions. Let's determine how translations impact the graph of the linear function f of x equals x, and the function f of x equals x is the basic function for the linear function family. A basic function is the simplest function of its type. You can translate the graph of f of x down 5 units by moving each point 5 units down. The transformed graph is labeled mx. To translate the point -2, -2 on f of x, subtract 5 units from the output, or the y value. The input value, or x value, remains unchanged. The coordinates of the translated point mx are -2 and -7, and the coordinates of the 4 additional points on f of x are translated for you. So if I'm moving down my y-axis, then I'm going to change my y values. If I go up my y-axis, I'm going to add to my y values. If I go down, I'm going to subtract from my y values. Number 1, consider translated graph mx. Identify the slope and the y-intercept of the graph of the function, then write the equation for the function in general form. All right, so we're going to look at this graph right here. I can see that this right here is my y-intercept. Whenever x is 0, that's my y-intercept. You can also see on your graph for mx that that point crosses at -5. And that's your y-intercept. So I know what my y-intercept is. Now we need to know what my slope is. Well, there's two ways you can do it. I can take the difference of my y's, which will be -6 minus -7, over the difference of my x's, which would be -2 minus -1 minus -2, which gives me a +1/1, which gives me a slope of 1. If I go look at my graph, I would see that it's also my rise over my run is going up by 1 and over 1 each time. So it still gives me 1. So my equation for number 1 for mx over the function of mx is 1x minus 5. Or I could simply write x minus 5. 1 is understood in front of your x. Number 2, translate f of x again to create a new function p of x. Translate the graph of f of x up 5 units. Label your graph as p of x. Complete the table of the corresponding values. So I'm going up 5 units, so I'm going to add 5 to every single one of my y values since I'm going up the y-axis. My x values are going to stay the same, but my new y values are going to be 3, 4, 5, 6, and 7. And if I plot those points, I've got -2 and 3. And do I see that I'm going up 5 units? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And there's the graph of px. Part B, identify the slope and the y-intercept of the graph of the function, then write the equation for the general form. All right, so let's go back and put those values back in there the way we had them. And it says we need to identify the slope and the y-intercept of our new function. So here the difference in my y's, 4 minus 3 over -1 minus -2 would be 1 over 1 again. And I can see that my slope is 1 every single time, 1 over 1. My y-intercept is now shifted up from the origin, up 5 units. So for part B, my equation would be for p of x is 1x, or just x, plus 5. For basic function f of x equals x, the transformed function f of x plus d shows a vertical translation of the function. This translation affects the output values or y values of the function. For d is greater than 0, and the resulting graph vertically shifts up for d is less than 0. The resulting graph vertically shifts down. The distance graph is shifted in the absolute value of d. Compare the values of f2 and p2. How did the transformation of the function affect the value of the function at x equals 2? So let's go look back at our values. So in x equals 2 for the original graph, we had 2 equals 2. For the transformed graph, we had 2 and 7. So we increased by 5. So when we had f of 2, it equals 2. When we had p of 2, it equals 7. The vertical translation increased the value of the function at x equals 2. Consider the graph j of x, 2x minus 1. Translate the graph j of x up 4 units. Label the graph as q of x, then write the equation for q of x. All right, so we're shifting this up 4 units. So 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And we're going to label this q of x. And we need to write our function of q of x. My slope is going to be the same as j of x, so I'm going to keep the same slope. However, my y-intercept is going to change. It's not going to be -1. I shifted up 4 units, so 4 plus -1 gives me a +3. So that would be my new function. Part B, translate the graph of jx down 4 units and label the graph rx. So we're going to go down 4 units. So here's my original y-intercept, 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Whoops. I'm going to keep the same slope because all I did was translate it up and down my y-axis. So this is r of x. So r of x equals 2x. And I went down 4 units, so it's -1 minus 4. So my new y-intercept is going to be -5. For C, rewrite q of x and r of x in terms of x. I think I've already did that. D, compare the equations and graphs of j of x, q of x, and r of x. What do you notice? Well, like I've stated, they all have the same slope. Same slope. They're all parallel lines. They're all the same slope. Activity 3.2, vertical dilations of functions. In this activity, let's consider how dilations impact the graph of the linear function f of x equals x. Suppose the output values of f of x are changed by a factor of 4 to create a of x. Sketch the graph a of x to complete the table of values. So here, we're going to multiply by 4 for our a of x. So if I multiply this by 4, that gives me -8. Multiply this by 4, that gives me 4. That's going to stay 0. Gives me 4, and that gives me 8. So this is a dilation. A dilation means it's going to get bigger or smaller. Depends on what you're multiplying by. So we're going to sketch this graph. So we got -2, -8, -1, -4, 0 and 0, 1 and 4, 2 and 8. And there is our a of x. Hopefully your line's a little bit straighter than mine. For part B, it says identify the slope and the y-intercept of the function, then write the equation for a of x in general form. Well, my slope has changed. If you notice, it got steeper. And if I use the difference of -4 minus -8 over -1 minus -2, that gives me a +4 over 1. So my slope changes to 4. So let's see, a of x equals 4x. My y-intercept is still 0. My y-intercept is still 0. So a of x equals 4x. No need to write 0. Number 2, suppose the outputs values of f of x are changed by a factor of 2/3. So before we multiplied by 4, now we're going to multiply by 2/3 and create b of x. So -2 times 2/3 gives me -4/3. That'll be fun to graph. And -1 times 2/3 gives me -2/3. 0 times 2/3 is still 0. 1 times 2/3 is 2/3. And let's attempt to graph b of x. So -2 and -1 1 1/3. I'd say somewhere right there. -1 and 2/3. 0 and 0. I can do that one. 1 and 2/3. And 2 and 1 1/3 is the best I could get, and we need to have a straight line, so it gives you an idea of b of x. Part B, it says identify the slope and the y-intercept of b of x, then write the equation. So my slope here, let's say I take these two, 2/3 minus 0 over 1 minus 0. So that'll be 2/3 divided by 1, which will be 2/3. So b of x is 2/3. And then my y-intercept still stays 0. So b of x equals 2/3 x. And my y-intercept would still be 0. Number 3, suppose the output values of f of x are changed by a factor of -4 to create c of x. Sketch the graph of c of x and complete the table. So we're going to multiply by -4. So -2 times -4 gives me a +8. -1 times -4 gives me a +4. 0 times anything still say 0. 1 times -4 gives me a positive -4. 2 times -4 gives me -8. So we're going to graph c of x. So -2 and 8. -1 and 4. 0 and 0. 1 and -4. 2 and -8. And there is our function c of x. Part B, it says identify the slope and the y-intercept. So our y-intercept is still the origin, 0 and 0. Our slope, 4 minus 8. -1 minus -2 is -4 over 1. So here my slope has changed to -4. So c of x equals -4. X would be my function. And I'm not going to put +0 for my y-intercept. Let's look at number 4. Compare the values of f of -1 and c of -1. How did the transformation of the function affect the value at -1? When f of x, when f was -1, we had an output of -1. When c of -1, we had an output of 4. So we had a vertical dilation multiplied by the value function at x equals -1 by -4.